Architecture of Interoperable Information Systems. This session will introduce the concept and value of Architecture of Interoperable Information Systems, AIOS, which is a reference architecture for the development of interoperable enterprise information systems. Interoperability is the capability of autonomous organizations to execute a collaborative business process among them, by enabling their information systems to work together. AIOS provides a generic building plan for organizations to develop interoperable information systems, by systematically adjusting and extending their internal information systems. Overview of Architecture of Interoperable Information Systems. The Architecture of Interoperable Information Systems, AIOS, is a reference architecture for the development of interoperable enterprise information systems. It represents a generic building plan for organizations to develop interoperable information systems, by systematically adjusting and extending their internal information systems. AIOS combines concepts from service-oriented architecture, collaborative business, and business process modeling. An architecture of interoperable information systems can be defined as the building plan of a cross-organizational information system, which enables organizations to execute a collaborative business process among them. This architecture supports the development of systems that can work together while retaining as much independence as possible. Examples of AIOS. AIO is a reference architecture for the development of interoperable enterprise information systems. It helps organizations to execute collaborative business processes with other organizations by enabling their information systems to work together. It provides a generic building plan for adjusting and extending internal information systems to achieve interoperability. It consists of three main components: descriptions of architecture, methods for designing architecture, and organization of architects. For example, as shown in the figure, an organization that wants to collaborate with other organizations in the healthcare sector may use AIO to design and implement an interoperable information system that follows common standards and protocols. Structure of Interoperable Information Systems, IIS. Interoperable Information Systems, IIS, architecture consists of three main parts: the static part, the dynamic part, and the technical components. 1. The static part of the architecture defines the structure of the system. It specifies which information elements organizations must provide to their collaboration partners and how these elements can be optimally correlated to internal elements. 2. The dynamic part of the architecture describes the different building paths for implementing or adjusting interoperable information systems. It provides guidance to organizations on how to iteratively develop the elements mentioned in the static part. 3. The structure of interoperable information systems can be viewed along three orthogonal axes: collaborative views, enterprise dimensions, and levels of technical granularity. 1. Collaborative views represent the different perspectives of the collaborating organizations. Each view describes the information elements and exchange sequences relevant to a specific collaboration scenario. 2. Enterprise dimensions represent the different aspects of an organization's internal structure and processes. These dimensions help to align the external collaboration requirements with the internal capabilities of the organization. 3. Levels of technical granularity represent the different levels of detail at which the architecture can be specified. At higher levels of granularity, the architecture provides more detailed guidance on how to implement interoperable information systems. Collaborative views. In the context of interoperable information systems, IIS, collaborative views provide different perspectives on the information system elements. There are three types of collaborative views: private, public, and global. 1. The private view comprises only the internally visible information system elements. It represents the organization's internal perspective on its information systems. 2. The public view acts as an interface to the internal, private system elements. It protects internal systems and enables interoperability without the need for significant changes to the internal systems. 3. The global view can be used to correlate and connect the public views of different systems. It provides a common perspective on the information system elements that are relevant to collaboration between organizations. Enterprise dimensions. Enterprise dimensions represent the different aspects of an organization's internal structure and processes. These dimensions help to align the external collaboration requirements with the internal capabilities of the organization. There are 4 enterprise dimensions: organizational, data, function, and process. 1. In the organizational dimension, roles, units, and other organizational elements relevant for collaboration are described and related to internal elements. This ensures that collaboration partners have a common understanding of the interacting roles. 2. In the data dimension, document types used in collaboration are defined and related to internally used document types. 3. In the function dimension, business functions and services offered in collaboration are described. 4. In the process dimension, the processes that each organization offers are described, as well as how these public processes are related to adjacent processes of partner organizations. In combination with the collaborative views axis, private, public, and global views on processes, functions, data, and organizational roles are provided. Levels of technical granularity. At the business level, processes to be automated are described from a technique-independent perspective. In MDA, this level is referred to as the CIM level. At the technical level, the IT concept is described by enriching the models from the first level with technical details. For example, instead of business functions, components are described at a coarse-grained, conceptual level. At the execution level, models are machine-interpretable and can be used during runtime in the execution of processes. Examples of technical granularity. The figure also strengthens the previous slide. It illustrates the description of system elements on different levels of technical granularity, supports a systematic development of collaborative information systems, starting with the business requirements definition and going all the way down to the code level. Apart from the construction aspect, thereby also a multidimensional interoperability description is provided, facilitating the synchronization of collaborating systems on each level. Similar to, for example, AIOS and OMG's MDA, 3 levels are used. 1. Business level. Here the processes to be automated are described from a technique-independent level. In MDA, this level is referred to as CIM level. 2. Technical level. Here the IT concept is described. Therefore, the models from the first level are technically enriched. For example, instead of business functions, now components are described, but still on a coarse-grained, conceptual level. Since the models on the second level represent the basis for an automated generation of executable code, they might have to be further adapted to fit implementation level constraints. 3. Execution level. Here the models are machine interpretable and can be used during runtime in the execution of processes. Summary and takeaways. Let us conclude this presentation. Enterprise architecture is a discipline that helps align business goals and strategies with IT solutions and infrastructure. It provides a holistic view of an organization's structure, processes, information systems, and technology assets, and how they interrelate and support the enterprise's mission and vision. Enterprise architecture involves the use of frameworks, methods, standards, and technologies to plan, develop, implement, govern, and maintain the architecture of the enterprise and its information systems. Enterprise architecture enables interoperability among heterogeneous information systems within and across enterprises, which is essential for collaborative business processes, and is applicable in various domains and industries and can improve the performance, efficiency, agility, and innovation of the enterprise. This is all about enterprise architecture. Thank you for your attention and participation. I hope you enjoyed the presentation and learned something new. If you have any questions or feedback, please feel free to contact me or leave a comment.